You know that perfect arc a ball makes when you throw it? Or the shape of a satellite dish? Well, that beautiful curve is called a parabola. And today, we're going to unlock its secrets using something called a quadratic function. When you look at an equation like this, it might just seem like a random jumble of letters and numbers. But it's not. It's actually a story. It's a blueprint for a perfect, elegant curve. And in the next few minutes, we're going to learn exactly how to read that story.
So here's our game plan. We'll start with the basics, what these things even are. Then we'll decode the simplest possible graph. After that, we'll learn how to move that graph all over the place. And finally, we'll put all the pieces together. Let's do this. Okay, first things first. Before we can do anything cool, we have to get our terms straight and properly meet the star of our show.
So this is the official definition. A quadratic function is basically any function where the most powerful part is an x squared. See that little x squared term? That's the magic ingredient. That's what takes a boring old straight line and bends it into our awesome curve. And you'll notice a can't be 0. Why? Because if it was, that x squared term would just vanish, and poof, we're back to a straight line.
Now, to talk about this shape, we need a little bit of lingo. Just 3 words. The U-shaped curve itself, that's the parabola. Now, every parabola is perfectly symmetrical, right? The line that cuts it right down the middle is its axis. And finally, that special point where the curve makes its turn, either the very bottom or the very top, that's the vertex. Parabola, axis, vertex. Got it? Good.
All right, now let's strip everything away. Let's look at the absolute simplest, most basic quadratic function there is. Y equals ax squared. You're about to see how just one little letter, a, is secretly running the whole show.
So, the first secret of a is all about direction, and it's so simple. If a is a positive number, the parabola opens upward, kind of like a smile. This means its vertex is the lowest point, a minimum. But if a is negative, the whole thing flips upside down and opens downward, like a frown. And now its vertex is the highest point, a maximum. It's really that straightforward.
But a does more than just point the way. The size of a, what we call its absolute value, controls how wide or narrow the parabola is. The bigger that number is, the steeper and skinnier the curve gets. Think of it like this. An a of 3 yanks the curve upward 3 times faster than an a of 1, so it ends up looking much, much narrower. Okay, so now we know how to shape our parabola, right? We can make it smile or frown, make it wide or skinny, but it's kind of stuck at the center of the graph. What if we want to move it? Well, let's take our little parabola on a journey.
Moving it up and down, that's the easy part. You just tack a number onto the very end of the equation. We'll call it q. You want to move the graph up by 5 units? Just add a plus 5. Want to move it down by 2? Add a negative 2, or, just subtract 2. This q value gives you direct control over the vertical position. Simple as that.
All right, now moving it side to side. This one's a little tricky, so pay attention. This happens inside the parentheses with the x. The equation becomes y equals a times, in parentheses, x minus p squared. Now here's the weird part. Notice that minus sign. It's kind of backwards from what you'd expect. If you see x minus 3 in there, it actually moves the graph 3 units to the right. And if you see x plus 3, that's like saying x minus negative 3, so it moves 3 units to the left. And of course, we can do both at the same time. This is where it all comes together. The p-value inside the parentheses moves it left and right, and the q-value tacked on the end moves it up and down. With p and q, we can pick up our parabola and plop it down anywhere on the graph we want. So here's the really, really cool part. This form of the equation, which we call the standard form, is like a secret treasure map. It literally tells you the exact location of the vertex. The vertex isn't at 0, 0 anymore. Its new home is at the point P, Q. And since the axis of symmetry always cuts right through the vertex, we know its new equation is just x equals P. All right, let's head into our final section and see how all of this builds into an incredibly powerful tool. We are going to put every single thing we've learned together now. Consider this table your master key. It's your cheat sheet for everything parabola. A controls the shape, which way it opens, and how skinny it is. P controls the horizontal position, left and right, and Q controls the vertical position, up and down. If you understand these 3 letters, you can understand any parabola out there. So, okay, this is all cool theory, but what can we actually do with it? Well, let's try a real problem. Imagine I tell you the vertex of a parabola, and I give you one other random point that it passes through. Can we figure out its exact equation? You bet we can. Let's walk through it together. Step 1, we take our vertex, which is at 2, 1.
That gives us our p and q. So we can immediately set up our equation as y equals a times x minus 2 squared plus 1. See? The only thing we don't know is a. Step 2. We use that other point we were given, 3 minus 1. We just plug in 3 for x and negative 1 for y. Step 3. Now we just have to do a little bit of algebra. The equation simplifies and we solve it to find that a must be negative 2. And finally, step 4, we put our value for a back into the equation. And there it is. The final complete equation for that one specific parabola is y equals negative 2 times x minus 2 squared plus 1.
And just so you know, that more complicated-looking equation we saw at the very beginning, the y equals ax squared plus bx plus c1, that's not some different, scary kind of function. It's actually just our standard form in disguise. You can always do a little bit of math to convert it and reveal all of its secrets, like where its vertex is hiding.
So now you have the key. Every U-shape you see out there in the world is really just that basic y equals x squared curve that's been stretched, maybe flipped over, and then shifted to its own special place on the map. The equation is its story. And now that you know how to read it, the only question is, what stories are you going to discover?